It is no longer news that Apache Airflow is one of the best workflow orchestration software out there. It's an open source tool and it is one of the best solutions out there. But what if you want to have a sprinkle of Apache Spark cluster, multiple programming languages like Python, Scala, and Java in the mix? How would you handle these kind of multiple dynamics? Well, in this project, I'll be showing you how you're going to be having a mix of this Apache Airflow, Apache Spark with master worker architecture, Docker, Java, Scala, and Python. So stay with me on this journey and let's get started. Why don't we start by creating a new project? I'll call the project Sparking Flow because I want it to have a representation of Spark and Airflow. So I'm going to call it Sparking Flow. I'll be using Python 3.11 and I'm going to be creating. Okay. Now, PyCharm is doing the initial bootstrapping. So once that is done, what I need to do in the terminal, I'll be creating some folders and files to serve as our base folders. Then we work our way up from there. So I'm going to start by creating DAG. So I'm going to say make directory DAGs, and then we're going to have a directory for jobs. Aside from that, we need our Docker file because we're going to be containerizing the project. Okay, so I'm going to have touch Airflow environment, Docker compose, YAML, and Docker file. And also I'm going to have a Docker ignore. Okay, so once these are done, the next thing that I need to do is to continue with the architecture of the system. So I'll go into the Docker compose and I'm going to just copy paste the architecture in there. So right now, to talk through them, I have services. And if you look at the services, I have 5 services. Okay. And each of the services, one is Spark Master, Spark Worker, Postgres, Web Server, and the Scheduler. The Spark Master and the Spark Worker, they are inheriting from Spark Common, which is the base image. And if you look at the Spark Common, it's have an image of Bitnami Spark latest and having a volume of jobs mapped to Bitnami Spark jobs on the container and then this network. The reason why I'm doing this is to apply a principle called don't repeat yourself, the dry. Okay, as much as possible, you want to minimize the code replications in your application. So once you change something somewhere, you don't keep changing it every other places. Okay, so aside that, having some properties that are different, something like the environment and the dependencies. And if you look at the command, I have my master command with this, and the worker command is this, which in the worker, you have to pass in the master URL. Aside that, I have a Postgres DB. I'm using Postgres 14, but you can use any of the versions of Postgres that you like. Okay, doesn't really matter. So far it's Postgres 12 and above because of the dependencies. Okay. I have the environment and then the network. Then for the web server and the scheduler, they have the same properties majorly, and they are inheriting from Airflow common. Airflow common, the command is web server. In here, the command is this, where I'm doing a DB migration. I'm creating this user with the username of admin, first name Yusuf, last name Ganu, role is admin, email scholar and at gmail.com, then password is admin, Airflow is the scheduler to bring up the scheduler instance. And if you look at the Airflow common, is here. These are the build contexts. So they are inheriting from the Docker file, having an env with this username and password, and the volumes. These are the volumes that are mapped into that. And it's depending on Postgres, and then they have the same network. So that's the basic overview of the system architecture. So this is going to create the master worker architecture for us. on our Docker instance, as well as web scheduler and web server on Airflow, having a Postgres database as our backend. And just continue to the Docker file. And inside the Docker file, I'll just copy paste the Docker steps. So I'm going to have the inheritance is going to be pulling the image from 2.7, Python 3.11. I'm going to be switching to the root user to install the container dependencies. And it's important you have an OpenJDK in there because of the Spark cluster and the submission. Okay. So I'm submitting to this, and I'm switching back to user Airflow to install these dependencies. So we're going to be running these same dependencies on our local system by the time we want to start coding in our DAG. Then the last thing we need to do is inside our Airflow env, we need to just have our environment variables in there. So I'm going to have the load example is false. I'll be using local executor. In the past, if you followed this channel for some time, we've been using sequential executor. We've been using celery executor, and then now we've also currently using the local executor. In future projects, we are going to be attempting to use the Kubernetes executor. So stay tuned for that. And we are using the PostgreSDB, and the web server URL is this, and the secret key is this. Now, once these are set up, the only thing that I need to do next is just to exclude the venv, okay? And I have a folder I've created by PyCharm called PyCatch, and I have some other ones like asterisk.pyo. I think I need to exclude the git from there too, and maybe pyc. Okay, anything asterisk.pyc. All right, so once that is done, the next thing we want to do is spin up our instance and see if the environment is set up and ready to run. So I'm going to just close this, and I'll close that, and I'll close this. Good. So I'll just come back to my terminal, and I'll say docker compose up in detached mode. It takes a few seconds. Okay, so it looks like this is creating directly. So docker compose, I'll be doing down. So it needs to create the base image. So the reason why you're saying created directly without pulling the image is because I already wrote something like this before. Okay, so I just go back in there. I'm going to have docker compose up detached, then I have the flag of build so that I can rebuild the image, and it's not using the previous image from my previous project. So going back in there, I just added the flag of build, and you can see it's building everything again from the scratch. So you should see something related to this. But the reason why you're seeing some cache in here is because I already have some base image in my system. So right now, the containers are started, and let's see if everything is fine. So going back to the scheduler, in our scheduler, the scheduler is coming in, and the scheduler is ready to rock and roll. And in the web server, it says, of course, because this is the first time that you're running this. This is not going to be something recurrent. It's just for the first time anyways. So I'm just going to go back into my terminal. You can either restart it in here, start or restart, or go back into your terminal and just do docker compose or detached. Okay, and it's going to get it started again. And if you go back into the web server, then we should be having new installations. You can see them coming in there, and it's starting the GUnicorn, which is the web server. On the UI, I'm just going to go to the UI, and you can see that in here, I'll just go to localhost 8080. And you can see that our Airflow instance is up and running. So let's test if the admin username and password is available and is set up properly. Admin. Okay, I'm going to sign in. And you can see that we have our Airflow setup, and you can see the cluster activity. The cluster is healthy and is ready to accept connections. So the next thing we want to do is we want to check if our Spark cluster also is up and running. So going back to our Docker, you can see we exposed 7077 as our submission port and 9090 as our web server UI. So if I go to this or click on this, or I go into my browser and I click localhost 9090 is the same. Just go to this URL and you'll be fine. So our Spark master is ready to rock and roll. It has a single worker, and this is the worker ID, and is currently alive with 1 gig memory and 2 cores. Good. So the next thing we want to do, I want to show you how you can add multiple workers in case you want to increase the compute power in the system. So going back in here, just come back to the Docker Compose, and applying the principle of dry, you might want to go back in here, extrapolate these properties outside of here, and then you can duplicate it multiple times, just having Spark worker 1, 2, 3, 4, as many as possible. Okay, so you just put this in something like an Airflow common like this, maybe Spark common worker, something like that, and then put the properties in there. Then you can inherit in the other workers. Okay, and that is how to get the architecture started. In the next section, we're going to be going into our DAG. So we've created the architecture right now.